You're welcome to today's class. Today we'll be discussing how to find the mode from interpolation. In last class we discussed how to find the mode using the histogram. So today discussing how to find the mode and later the median from interpolation, and also how to find the median using the cumulative frequency curve. Okay, quickly, the mode is defined by the formula Lm plus theta 1 over theta 2 plus theta 1 into C, or you say Lm plus theta 1 over theta 1 plus theta 2 into C. Now, what is Lm? Lm is defined as the lower class boundary of the modal class. That is, if you can get the modal class, then get the lower class boundary of that modal class. That is Lm. Delta 1 is the difference between the frequency of the modal class and the class before it. Don't worry, when we take an example, you see that. Theta 2 is the difference between the frequency of the modal class and the class after it. While C is known as the class width, or what we call the class size of the modal class. So it means the first thing you need to do is to identify the modal class. It's very important to get the rest variables. Okay, let's take one example. Using the table given in the example above. Okay, that's this table. Using this table above, I have to calculate the mode. Using the table given above, calculate the mode. That's the complete question. Okay, so the first thing to do is what? Identify the modal class. Look at the table. What is the modal class in this table? Now, the mode itself is the value with the highest frequency. So you can say the modal class is what? 22 to 24. Why? Because the highest frequency is what? 35. Now the class having that highest frequency is class 22 to 24. You might be asked that state the modal class. Just say, I told you modal class. When I asked to state anything class, your answer should be given in terms of class interval. That is what? 22 to 24. Now, first thing to do is what? Get Lm. What is Lm? Lower class boundary of the modal class. Lower class boundary of the modal class. Now, this is the class. This is the class interval. So go do the class boundary. Of course, that's not difficult. After doing that, the class boundary, the lower class limit, or what we call boundary now, of the modal class is what? 21.5. This one. So this is the corresponding lower class limit of the median class, of the modal class. Sorry. Okay. Afterwards, now you have to find delta 1 too. How then do we find delta 1? You can say delta 1 is what? Difference between the frequency of the modal class and the class before it. Now, in this example, since 35 is the highest frequency, the class 22 to 24 is the modal class. So which frequency is before 35? That's frequency 30. So you do 35 minus 30. That gives the difference between the modal class and the class before it. So you get 5. 35 minus 30 gives 5. Okay, so you can see that we have 5 in our solution. Now delta 2. How do we get delta 2? Frequency of the modal class minus frequency of the class after. The frequency of the class after 35 is 24. So you say 35 minus 24, that gives us 11. Can you see that? Now C. What is C? This part needs to be well understood. Now C is called the class size. It is the measure or the gap between each interval. For instance, interval 16 to 18 means 16 to 18. Don't say 18 minus 16, that's 2. No, 16 to 18. So you count from 16, 16, 17, 18. So you have 3 as the class size, or what we call class width. Do you understand? So don't say 18 minus 16. You can say 19 to 21. 19, 20, 21. That gives us 3 as class size. So you record 3. Once you can get those variables, then you are done. Just input the variables into the formula that says mode equals to what? Lm plus delta 1 over delta 1 plus delta 2 times C. So Lm is 7.5. So plus 5 over 5 plus 11. What will 5 plus 11 give us? That gives us 16. So you have 5 over 16 equals to, okay, then times 3. Now 5 times 3 gives 15, so you have 15 over 16. Don't forget, when multiplying a fraction by a whole number, that whole number only multiplies the numerator. So you have 3 times 5 to give us 15. So the fraction 15 over 16 plus 21.5. You can see that I did the bracket first. Follow board maths. Then you add to 21.5 to give us 21.5 plus 0.9375. To do that well, you should get approximately 22.4. Yes. So you can round down to get 22. Yes. I believe that's clear. Okay, so let's quickly run down to median of group data. Now, like the mode, we could find mode in two ways. We could use the histogram method, we could use the interpolation method. Likewise, for the median, also, you can use two methods as well. You might be asked to find the median using the cumulative frequency curve or by interpolation. So let's really talk about the cumulative frequency curve method, CFC method. Okay, the median of the group data can be determined from a cumulative frequency curve and from the interpolation formula, like I said earlier. Median from CFC curve. Now, how do you do that? Now, okay, let's take one example. It says the table below shows the masses of 50 students in a secondary school. You have the masses given in terms of class interval and of course the frequency. So you know this is a group data. Now to A, prepare a cumulative frequency table for the data, and B, draw the OG and use your graph to find the median. Of course, this is not new to you. To draw an OG, you need this table. You need the class interval, the frequency, then the cumulative frequency. This is how to cumulate. Transfer the first frequency to the first frequency, then 3 plus 7 gives 10, 10 plus 9, 19, and so on and so forth. And you need the upper class boundary, don't forget, which is 40.5, 90.5, 24.5, etc. When you're done, plot your cumulative frequency against upper class boundary, and you get this graph. Now, when you are done with the graph, we are done with A. Now, if this is not clear, download the previous video on how to plot a cumulative frequency curve to understand better. Now for B, draw the ogive and use the graph to find the median. So aim here is to find the median. How do we find the median using the cumulative frequency curve? The first thing is identify the median class. To identify the modal class, we look at the frequency, look at the class with the highest frequency. That class is what? Modal class. But for median class, we need to do some rough estimate. Median is a central value, right? So in group data, what we do is we add from on top and we add from below the frequency. Adding from the top, we have 3 plus 7 plus 9 plus, because our total frequency is 50. Half of 50 is what? 25. So we say to find the median, find n over 2 and check the table on the curve. Therefore, n over 2, n here means what? Total frequency, which is 50. In the question, you have 50 students. So 50 over 2 gives 25. After doing that, you add from top and from below until you get 25. Now, adding from on top, or from the top, we have 3 plus 7, 10. 10 plus 9, 19. 19 plus 5 gives 24. 24 plus something in this 11 will give us 25. So we need 1 out of 11. Therefore, 11, the class with 11 as the frequency is the median class. Okay, let's try adding from Binet. 9 plus 6 gives what? 15. 15 plus 11 gives us what? We have what? 15 plus 11 gives us what? 26. So we have 25 in this 11. Therefore, the class 30 to 34 gives what? The median class. That's the median class. Do you understand? So the first thing to do is identify the median class. By doing this rough estimate, you add from the top of the frequency and from beneath the frequency until you get to half of the total frequency. Now, if we are done with that, so you go to the cumulative frequency curve. and check 25. Yes, check 25 on the cumulative frequency axis, on the vertical axis. Then trace it down, trace it up to the curve. Can you see this 25 here? 25, I have 25 here. Then you trace this line. You can see. Then when you get here, when you get to this point, you now trace it down straight with your graph. Use your straight ruler to draw that, to touch the curve. Then draw it down to touch one small box after 29.5. Now, how do we read? Look at this class boundary here. 40.5 to 19.5 gives us what? If you say 19 minus 14, that gives us what? 5. So each big box, each 2cm box gives 5. Each tiny box gives 5 over 10, because you have 10 tiny boxes in one big box. So each small box is 0.5. So it's like this. If you plot a graph very well on your graph book, you get it at a small box after 29.5. That will give us 29.5 plus 0.5. So that will give us 30. Therefore, approximately your median is 30 kilogram. Can you see that? So on the checked on the fifth position on the cumulative frequency and traced to the upper class boundary, you get a median as what? 30 kilogram approximately. Okay, quickly let's talk about the median from interpolation. We've talked about the median from the cumulative frequency curve. Now, what about the median from interpolation? The median has its own formula too, just like the mode, but the formula is different. The median is given as L1 plus N over 2 minus CFM over FM, everything into C. Okay, what's L1? L1 is defined as the lower class boundary of the median class. The lower class boundary of the median class. Now, CFM means cumulative frequency of the class before the median class. FM, frequency of the median class. C, same thing as class size or class width, and total frequency. Now, we have to solve the same problem, using the table given above. In the table given above, our median class is what? 30 to 34. That's the median class. Can you see that? Now, what is the lower class boundary of the median class? Since this is the median class, lower class boundary is what? Is remove 0.5 from 30. That gives us what? 29.5. Can you see that? 29.5. That's the lower class boundary of the median class. Can you see that? That is L1. Now CFM, frequency, the cumulative frequency, don't forget. So you need to do cumulative frequency whenever you are calculating median using interpolation method. So the cumulative frequency of before the median class, not of now. Now look at the cumulative frequency here. The one before the median class is what? 24, not 35. 35 is the what? CFM for the median class, but 24 is the one before the median class. So we have 24 as CFM. Now to find FM, that is what? The frequency of the median class itself. So you look at the frequency of the median class, and that's what? 11. Can you see that? The frequency of the median class is 11. If you pick that, then C, in this case, look at C, 30 to 34. I told you not 34 to 30, not 34 minus 30. It is what? 30 to 34. You count 30, 31, 32, 33, 34. That's 5. Therefore, we have 5 as C. Now, input all this in the formula. We have 29.5 as L1 plus N over 2. Now, N is what? 50. Because we have 50 students. Over 2, that gives us 25. Minus CFM, cumulative frequency before the median class, that's what? 24. Over FM, the frequency of the median class, 11. Then times 5. So if you do 25 minus 24, you get 1 over 11. 1 over 11, then times 5. That's 5 over 11. Right? If you do that, you get 29.5 plus 0.5. So not 5 here. Sorry, this should be 0.5. If you do the sum, you get 30 kilogram. Can you see that? So you get approximately 30 kilogram, which is our answer. Alright, so as your assignment, you have all this evaluation, you have the weekend assignment, you have to do everything. I hope the class is clear. So you can reach me in case you have a question. Thank you.